Okay, so now let's talk about what factors influence the fate of a planet. And from this chart, you should notice that up at the top, there are three main things that are going to determine the fate of a planet. So number one is going to be its mass. How big was the planet? Okay, the second thing is going to be how far is this object from the sun? And then the third thing is, does this object have a relatively large moon in orbit around it? So let's look at the first factor, the mass. So the mass is going to determine the gravity of the planet. The larger a planet is, the more mass it has, the higher its gravity is going to be. And it's also going to, the mass is also going to determine heat retention. So a small mass planet is going to lose heat faster than a large planet. So I want you to think of potatoes. So imagine that you've got a big baked potato and a little baked potato. So you take the potatoes, you put them both in the oven, and you heat them until they're both the same temperature. And then you take the big potato and the little potato out, you put them on the counter, and then every 5 minutes you touch each one of them with your finger. Don't burn yourself, but you would find that after a half hour has gone by, that little potato has significantly cooled off, but the big one has not. So the bigger the planet, the slower it's going to cool off. Okay, who cares? So what difference does this make? So let's go a little bit further in the chart and notice that the size of the planet is going to determine its plate tectonics. A hotter planet is going to have more plate tectonics, more volcanoes than a little one. And what does plate tectonics do? Plate tectonics creates the atmosphere of the planet. And also, the atmosphere is held down by the gravity of the planet. So that if you have a little planet, it's going to cool off quickly, its plate tectonics is going to go away, the volcanoes are going to be greatly reduced, so it's not going to be producing as much gas, and since it's so small, the gas that it does produce can't escape into outer space. So it's not going to have very much of an atmosphere. Okay, who cares? Another thing about the heat retention is that a small planet, if it cools off on the inside, is not going to have much of a magnetic field. Okay, now let's go down to the next level. So the atmosphere. So what does the atmosphere of a planet control? Okay, it's going to, if there's water or something that could be turned into a liquid in that atmosphere, that could cause erosion. An atmosphere acts as a meteor shield so that objects have a hard time getting through the atmosphere and making gigantic craters on the surface of the planet. The atmosphere holds water down. So the pressure of an atmosphere helps to keep water in the liquid form. If you have a thin atmosphere, it won't have much pressure, and then that means that liquid ocean can evaporate and turn into a gas. And so the oceans will go away if that happens. And then the atmosphere controls the temperature of the atmosphere. So remember we talked about the greenhouse effect. So a thicker atmosphere is going to have a warmer climate than a thin atmosphere. Okay, and then finally, what does water do? Okay, so if you have oceans, it helps to absorb carbon dioxide, and that helps to cool the planet. Okay, water helps to moderate the climate of a planet. So that, think about Hawaii. Hawaii is surrounded by water, and so during the summertime, Hawaii is not so hot. During the winter time, Hawaii is not so cold because of the moderating effect of its water that surrounds it. Okay, and then what about distance from the sun? Well, this one's pretty easy. The closer you are to the sun, the hotter it's going to be. The further away you are, the cooler it's going to be. Another thing, though, about the sun is it has a solar wind. And then that solar wind is debris that is blown off the sun. And that solar wind can actually erode the atmosphere off of a planet. It can actually blow that atmosphere off of a planet. So that's going to be very important for some of the objects in our solar system. And then the last thing is, what about the presence of a large moon? So I want you to think about a person who is walking across a tightrope. Okay, so they're walking across it. How do they walk? So do they walk with their arms held at their sides? No. They walk with their arms out like this in order to help balance themselves. And better yet is if they got a pole. If they got a 10-foot pole, the weight at the end of those poles will help to keep you from tipping over. That's what our moon does. So our moon is relatively large in comparison to our planet. And that moon helps to keep the Earth from tilting too much. Now, the Earth is tilted at 23 degrees. And we found that that causes the seasons on the Earth. But without our moon, the tilt of the Earth over millions of years would shift more and less. So the tilt of the Earth would be shifting like this. Now, if it shifted like this, that's not so bad because that would mean that the seasons would be less severe. But if it shifted like this, more than 23 degrees, then that would mean the seasons would be more severe. And so life would have a hard time adapting to constant changes in the climate of the Earth over millions of years. So it's a good thing that the Earth has a relatively large moon. Okay, now what we're going to do is go through some different objects in our solar system, talk about how they're different than the Earth and why are they different than the Earth. So I'll see you in just a moment.